Well, welcome back to Workshop Friend. Today I'm going to have a look at parting off, and particularly parting off on my Colchester Student lathe. So until now I've used this parting tool holder with a cutting tool that has 1/8 width, and sometimes it works okay, sometimes it doesn't, and I suspect part of the problem is the overhang. So the minimum overhang I can reasonably get from the edge of the tool post, which is slightly beyond the top slide, is around about, what is that? Yeah, 2 5/8 inches, or about 67 millimeters. And I think that's one of the contributing factors to having had one or two foul ups. Now on my Myford lathe, when I went to a rear mounted inverted parting tool, I found it revolutionized parting off for me. So I made this dedicated tool post to sit on the rear of the machine, and you've probably seen in a number of my videos I do quite a lot of parting off, and this works very well. Now admittedly it's a slightly narrower tool than the one I'm proposing to have on my Colchester Student, but for the size of the machine I think this is a very successful tool post. So to the rear of the cross slide on the Colchester Student, we've got some mounting holes there, and I put set screws in here just to stop swarf from going through, but I think they are 5/16 UNC, and there are 4, and I believe that's for mounting a rear tool post. So I found this block of steel in my scrap box, and that will make a nice base. It just about covers those 4 holes adequately. And then I purchased a bar 3-inch diameter by about 6 inches long, and that can be mounted on there, and that will give me plenty of height to make a rear mounted tool post. Now I'm not going to use my existing parting tool holder. I just don't like that degree of overhang. I mean, the minimum overhang is quite considerable, and it wastes space on the machine apart from being less rigid. I'm going to go for one of those side mounted tool holders. I've ordered one, it's on its way. I've got some rough dimensions here. I can go ahead, start machining this base, and maybe start machining some of this. So the first thing I'm going to do is I'm going to take this over to the shaper and make these two sides flat and parallel. A couple of small toe clamps might have been helpful here, but in their absence I'm using this technique of just swapping the clamps around. It's not perfect, but it worked. Just taking time here to make sure that I'm clearing the clamps, and I've got a clear pathway for the ram. One of my viewers had pointed out in the comments that my shaping machine was running in reverse, so the forward stroke was faster than the return stroke. Unfortunately, the inverter has reset itself and it's doing the same thing again here. I need to change the wiring. So I've just given it a quick clean. I should have shampooed that edge while I was at it, but the edges come out nicely. I'll be surprised if this top surface is flat with all those clamp changes, but I'll check that out. I think what I'll do is I'll use the shaper to finish the edges, but I will mount it in the lathe to machine the other face and put the recess in, the circular recess, to accept the bar that comes on top. So I've been scraping this, and it's been necessary because the way I clamped this on the shaping machine, it certainly wasn't going to result in a flat surface, but it wasn't actually too bad. It's taken me about an hour, I guess, to get to this stage, and you can see here, we zoom in a little, you can see here there's a little patch that's not been that's not come up to the surface yet. The original machining marks are just there. So I'm going to continue to scrape this, and the reason for doing this, I want it to sit nice and flat on the top of the cross slide, so I'm not going to distort the cross slide, and it's going to be a good positive location on there. So hopefully you can see now we've got quite an area of coverage. Still, this corner's a bit low, so I'll try and bring that in. I'm not aiming for perfection, I'm just aiming for something here which sits nicely on the cross slide. This incidentally is just an old file, and I've just ground the end and honed it on a just on a oil stone, and the more I hone it and use it, the better it gets, really. It's not perfect, but it's good enough for this job. It's really surprisingly quick to go from a surface machined on my shaper to one like this, which is quite passable. Because having scraped it, you can feel the small burrs there, so I just go over it with my fine oil stone and just take those off and try to keep everything clean before I put it on top of my surface plate. You can still see that surface there is still got to get down to it. The oil stone is just beginning to, well, it's taking the top off the finish there, so it's very close to final size. It's probably passable now, but I'll go a bit further. Okay, it seems like it's a bit high in the middle there. I'm not sure if that's because of individual dings. No, I don't think it is. I think it's just generally high. So I'll just try and take a little bit off that and improve the bedding of my tool post on the rear of the cross slide. These are the 4 bolt holes, 1, 2, 3, 4. The 5/16 UNC bolts, holding down bolts. I think I'm going to stop there. It's actually quite difficult to cut this with my crude scraper. I'm not getting much material off it. It's not like this mild steel. And we'll return to machining this base. I've deburred the block now, so we've got the underside and the 4 edges all trued up. What I'm doing now is marking out for the holding down bolts and also a recess in there to locate the bar that sits on top. So I've got my drawing here. I don't expect you to be able to see the dimensions, but just to get a rough idea of what's going on. Originally I had aimed for 3 holding down bolts, 3/8 UNF, but I changed that for 4. The reason for that was to just provide a bit more rigidity, but more importantly than that, to be able to take the top off and rotate by 90 degrees. It could be that I'll want to use this not just for facing off, but for normal turning operations, but from the rear. So I thought having a 4-hole bolt pattern will enable me to rotate the whole thing by 90 degrees. I'm just working on the holes for these holding down bolts. I've marked out the center line here, and this radius here is the recess that needs to be turned. I'm not using my mill. I haven't had very good success so far picking up center holes using my feed dials. So what I thought I would do is just do this by eye. So I very carefully scribed the geometry out. I started with the center, which is the center line of the bar that sits on top, drew the radius in that needs to be turned, and then I divided it up and got these holes in at 45 degrees. I'm actually using a magnifying glass just to see where my first center pop is right on the crosshairs or not, and if it's not, then I'm using my automatic center punch just to slightly move things in the right direction and keep checking. We'll see how accurate I can get these holes and whether with nice fitting holes I can still take the top off and rotate it 90 degrees. Okay, I see that one's got to move slightly in along the radial line, so I can pick up the previous indentation and we'll just slightly move it in that direction. Say a touch more. This one's on the circumference, but it needs to be moved slightly that way. Just going to double check by checking the spacing. I've set the base plate up in my 4-jaw chuck with some aluminium pads there to protect the edges. Initially I set the center up by putting a tailstock center up against it, and then using my dial test indicator on here, rotating the chuck, I was able to get that running true. But I thought I would also check the concentricity of the holes that I've just drilled, and discovered that they're a bit out. So what I'm going to do is abandon this idea and just use the clock on the holes. Now it's a bit fiddly, but I think I will get a better overall result. We're going to aim to take the average of those and make that the center. Marking blue doesn't make for good photography, but anyway, hopefully you can see what's going on. So I'm just lining up the DTI with the first hole, and then rotate 180 degrees. This isn't exact because I have to just guess where the vertical position is, but it's near enough. It's enough to tell me that it's not concentric. So if I zero out on that one, we need to drop that down, say 4.5 thou. Okay, we've got a total run out now of 6 thou. I'm going to continue this and then come back later when it's done. So having got everything running concentric with the 4 holes, I'm clocking up the rear of the plate to make sure that there's no swash in there. I did it on the front first, but of course that's not machined and it's not really flat. So it's a bit tricky, but I think it's worth the patience to try and get this running square. So it looks like this has got to go in. As a matter of interest, I'm just going to compare that with where the original center mark is, and we'll see how much those 4 holes are out of center line. Yeah, that's not good. There's now a total run out of 15 thou. So my drilling technique isn't that good. I thought I could achieve better than that. But anyway, I picked up the new average center of these 4 holes, and that's what I'm going to use for subsequent machining. This is my tool height setting gauge, which I use frequently. I have another one for my other lathe. Together with standard packing pieces, I can usually set up a tool quite quickly. Fourth thou to go.